Welcome to Dave's Car, Part 1. From 1973 to 1978, I worked to start my own car company, and you can see in the picture the big cars, the completed car. It just first was brought out onto the street, and the 10th scale model was designed to be a lightweight, high-performance sports car, and is patterned after or inspired by the Porsche 917 Le Mans car, is in this picture, and the Porsche 91730K turbocharged car that won the Can-Am series with Mark Donohue driving. This is the specification sheet that gives the details of weight and width. Basically, it's 6 feet wide, 39 inches tall, weighs 2,150 pounds, ready to drive, and the bodywork's aluminum. The chassis from the roll bar forward is aluminum monocoque. The chassis from the roll bar back is a welded inch steel tube space frame. Okay, and this is the first sketches were made, and then drawings, and then a model was made to check out concepts, to check the stiffness of the chassis, and see if it looked good. And you'll see it's got a bit of a sweep up on the back that doesn't end up in the finished car. The back of the car is actually 2 inches lower than the roll bar. But it was a good way to test concepts, and things that worked out in the model ended up working out in the real car too. So that's the way the bodywork opens. That's the space frame with the engine, and that's very rigid. You can grab it with your two hands and try to twist it. It doesn't want to give at all. And I did redesign it after I found out it was too flexible. I redesigned it so that it was stiff. So this is an office for drawings, and this is the original. This is the inch square tubing subframe that goes inside the monocoque tub, and these are the hoops that go in the back of the monocoque tub, and the roll bar and the rear chassis attaches to that. So the aluminum is aircraft aluminum, 6061 T6, aircraft aluminum, about 60 thousandths for the tub, and about 50 thousandths for the linings in the tub. And these are the fuel tanks, the side pods we'll call them. And these are showing some of the details of how it was made. And you notice a 4-inch clearance between the fuel tank and the outside, and that's filled with high-density urethane foam when it's done. So you have a kind of a cushion like the inside of a motorcycle helmet there if you get hit from the side. And there's an inch on the bottom, inch on the inside, same thing. So these fuel tanks together actually held 35 gallons if you cared to put that much in, and they have internal baffles that control the fuel slosh. So this is the layout of the monocoque tub. So here's the pieces, the inside frame, the side pods with the fuel tanks inside, and now you'll see a series of pictures showing the assembly of the monocoque tub. So the rivets are all 1/8 inch stainless steel rivets, pop rivets. They rivet them from one side, and take two hands to pull on a rivet gun. And they have an 800-pound shear and tensile strength each rivet. So you add 3,000 rivets, and pretty soon you got a very, very strong structure. The body is also aluminum, half-hard aluminum alloy. It's also riveted. So it took 3,000 hours from start to finish, and over 4.5 years, that averages about 4 hours of work a day, every day, for 4.5 years. And I kept a diary, and I said, well, because I had to learn a lot of things and redesign suspension, I could actually make the second car in 3,000 hours of labor. So, so this is the inside. It's going to be the steering wheel, and this is the front. Now I've got a design suspension that you see here. Make it so you don't have too much bump steer. So mounts the brakes, and we'll go through that in the later series of pictures, show all the details. And this is just kind of the front frame or monocoque. And you'll see it ends up triangulated brace here. Now the steering wheel, you see it's mounting bearing. and the rack and pinion steering. You can see that it's from a Triumph TR2, and you have to extend the rack so the inner and outer pivots are in exactly the right place, and the length of the outer arm, the pivots, is exactly the right length. So this is the design of the shifting console. You'll see it in a second here. And the windshield put in position. Testing out the steering position. I think it was at 1.5 turns each direction. So you got like 2.3 turns lock to lock on the steering. So this is after it's attached to the rear space frame, which we'll get to in just a little bit. So all these pieces go together to form a very rigid structure. From above, and that's from underneath. And you'll see it's all flat aluminum underneath, so there's just like no air drag at all. And the tires are the largest street legal Goodyear tires made at the time, a 50 series. And they had a tread was like they used when their Le Mans winning GT40 car. Okay, now this is making the little subframe in the front of the tub to support the front bodywork. So I have know where it's supposed to be, and then you start welding in the components until you get a completed structure. So the front bodywork and the rear bodywork attach with 2 bolts that also act as bearings or pivots. So they can be actually removed by just removing 2 bolts and set aside. So this is the part of the roll bar. It's a horizontal hoop that the seat belt shoulder straps are going to attach to. It's important they be directly back from the top of your shoulder, so as you're thrown forward, it doesn't pinch your shoulders and have a injury that way. This is the way the front and the back lock together with this pin. Now the windshield. This is my special windshield shipping crate, and I had a little interesting episode getting in the windshield. It had to be, windshield is critical for the car, and it's very much like the 917 Porsche windshield, and they used it on a Chevron B16 sports racer back in England, and they actually made them out of safety glass, and a man in Texas was making a replica, and I ordered them from him. And the first one he sent me a broken one, so I made a custom box. You couldn't damage the windshield if you tried. And I sent him the box, said, put the replacement windshield in here, which he did. And he sent it back, airmail, very expensive. And it arrived, it had a defect in it, which he called and apologized for. But he never was going to send me another one, so I was just satisfied with an almost perfect windshield. Now this is making some of the suspension, front suspension redesign components. I found I had way too much bump steer, and so I threw away the original Porsche design front suspension, and I'm repositioning the upper A-arms. So these are the new supports for the bottom. And there's the new brace, diagonal brace. This is the end of the rack and pinion steering. You see I've modified the end of the machine, the parts for the rack to get the right length. And this is the bearing block that will support the steering wheel on the bottom of the dashboard. Now this, I just machined a shift knob out of, you see a whole big bar of aluminum. And this is the jack that lifts the car up from the side, goes under the end and can lift it from an inch off the ground, can lift it right up. So to make the body panels, you actually clamp a wood panel on each side, and then you just slowly bend the piece over with a wood block and a hammer. Okay, this is from the front with the body, rear body pretty much completed. And this is the underside of the dashboard. And these are some of the views as the rack and pinion steering's attached. And you've got the, this is the clutch cylinder. The other one was the brake master cylinder. Now the clutch hydraulic cylinder is attached, which operates the clutch with a remote cylinder. This is the steel plates that go to make the brake pedal arms. So I cut those out of steel plate and bended them to get the right shape, made the pedals. And you see there's holes here, so that's so you can adjust the length. And some boots with 2x4s in them to simulate the foot pedal action. So pretty much whatever you want. You start with some bar stock and machine it, or steel plate and cut it out, and steel tubing and shape it, weld it in. All the welds are heliarc welded with high strength rod. So it's just pure arc, and you just melt the, it's kind of like brazing, and melt the steel into it. So this is the unit that goes on the side of the driver with the parking brake and the shifter. And it also has a control there for from the Corvette racing catalog to hydraulically adjust the rear brakes. So how much work goes to the rear brakes. So these are some of the parts that are going to go into the dashboard. And it's actually a mahogany dashboard, and it's structural. So it's part of the actual structure of the interior. So putting in new wiring, you got to keep track of all the wiring and how it goes to the circuit breakers and the connects to the plugs and so on. And this is the little aluminum panel that goes under the dash. It has all the headlight switches and horn switches and starter switches and pump switches and so on. Now you see it in place. And there's a tachometer that's soon to go in. And the wiring behind the dash as it's being added. Starting to get organized a little bit. Now I've started to organize it and wrap it with the protective covers to keep it organized and safe from harm. These are the headlight relays, because the headlights are all high powered, so you just throw a relay and the relay turns the power on. This is the windshield wiper motor being installed. And the windshield motor and wiper is off a Ford truck, so it swipes back and forth across. It's a real good motion. It's parked on the passenger side. So this is good. Some of the wiring goes down the passenger side of the car under a cover. And it comes out the back. And behind the back of the roll bar is where the ignition systems for the engine are located. So you can see now it's pretty much installed. And it's all wrapped up. Now underneath here, these are all the pumps that operate the water-cooled oil pan and various pumps and filter cap, and there's a fuel pump. And these are actually cooled by a NACA duct underneath the chassis. It brings air up and keeps it cool. So this is the heater unit, and a little for defroster and for warming the car. It's actually off a Datsun pickup, and it uses heat pulled out of the engine oil, and you can turn it on when you want it. My wife checking out the steering position, and the steering wheel is adjustable fore and aft. The pedals are adjustable fore and aft, but it's kind of a loosen the locking bolt, move it, and retighten it. So here's the will be the foam blocks that are glued in place, and then this is a big piece of material that my mother-in-law sewed Velcro into it. So the Velcro strips are attached, and the whole upholstery just goes in with Velcro, so you can take the whole thing out if you want. And the seatbelt harnesses are safety, like Simmons, or the Rupert Parachute Company, I guess. So the official heavy-duty, quick-release racing seatbelts. My niece going to a car show with the model. Okay, now this is the rear space frame. I think this whole frame weighs 75 pounds, and this goes from the roll bar back, supports the engine, transmission, suspension, rear bodywork. And each tube forms a triangle, so it's absolutely rigid. And I think some joints have 9 tubes coming into the joint, so they're all hand welded. And these are this is where the engine bay is, and this is the part that attaches to the monocoque tub with 8 bolts. And this is showing some of the mounting of different parts. These are where the suspension attaches. So you just find where a part should be and you make a bracket to make it go there, and make everything to work out right. Having a little fun here test driving the chassis and Karen. This is the top of the roll bar attachment before the roll bar was made, and you see the arms of control, the rear suspension, and that's right out of the Porsche engineering drawings. And their turnbuckles are male-female, so if you want to adjust this wheel in or out, you just loosen the lock nut, turn the control rod, and it automatically pulls it in or pulls it out, and you lock it back down. So all the joints are hemispherical, I believe they call metal-to-metal contact, so there's no play in the suspension. It's just solid. And there's brackets being added for the anti-roll bar. And there's an anti-roll bar in place, which is stress-proof steel stock, and you use heat bend it, and it's good for making a springy roll bar. And they're both adjustable front and rear. This is the shift linkage. You have left-hand shift because the transmission used to point forward. Now it points back. So you have to take the motion around the back of the transmission and operate the transaxle, which is Corvette type gears, and it's a Chevy Corvair transaxle with extra heavy duty gears and a limited slip differential. So this is the slave for the clutch. So it's hydraulically operated and connected. And this is the engine bay of the back space frame. Now we're getting ready to do some painting. And this is after it's been painted. So the frames were all one color, and the control arms were all one color, and the body was a different color. So you could kind of see color-wise everything was coated. So here we're putting on aluminum panels under the engine bay and on the side here. And this is behind the roll bar in front of the rear wheels. And these are the parts we're talking about being colored. And this is brackets and bearings for the emergency brake. And this little pad is what where the engine bolts in. There's a ladder frame, and there's 4 bolts in 4 places, and you take those bolts off, and then the engine comes out the front of the back space frame. So you kind of temporary clamp it, and then you drill holes, clean them up, then rivet the parts on if they're riveted, weld them on if they're riveted, welded. Now this is the support for the roll bar. It's being attached and measured. And this is the bracket that holds the rear bodywork, and this is the pivot. So and it pivots it forward and back. So there's a completed space frame with engine, suspension, and ready to attach to the monocoque tub. Now this is making the subframe in the back that's going to support the rear bodywork. Pieces go on a piece at a time, and the pivots are on the outside of where the bodywork attaches with 2 bolts. Okay, you can see the rear suspension there with the anti-roll bar. Battery, good battery. And this is nearing drivable now. I have to still rebuild the engine and put in some heavy-duty parts. And there's still work hooking up the exhaust and intake manifolds and so on. So this is testing the suspension movement there. You can see how much. 5 inches bump up and 2 inches drop down, so 7 inches of suspension travel. So now we need to mount the special turbocharger muffler. And it's got a little more of a throaty sound because it's Pretty large pipe goes all the way through it. So you see the 2 units, and you can just kind of, with a lift on a crane, and just move the parts back and forth. Take the engine out and so on. So these are just different pictures showing how you can do maintenance, or how you're putting it back together again. This is the front where the suspension is going to been attached. I took most of these with black and white Kodak Tri-X 35 millimeter, and I tried to do them available light without a flash. So the photo quality sometimes is marginal, but I've done the best I can here in editing. So this is showing how the steering wheel is going to be attached, and this will be the lockdown for the steering wheel. There I am welding with heliarc welding, and there's the weld, and there's the steering wheel support. And the steering wheel is kind of interesting. It's actually a race mark, heliarc welded aluminum leather, Italian leather covered steering wheel made by Mark Donahue, who was the race driver that drove the 1917 30K race cars and drove Formula One, and unfortunately was killed in a Formula One practice accident. So this is some of the linkage for the transmission shifting. So it goes out, goes across, goes back, and then the motion is turned into fore and aft from the rear. This is the support for the shift linkage, and it's lubrication too. That's from the rear of the transaxle. And again, these are metal joints. I started with some plastic lined one, but the heat of the muffler would just lock them up. So they have to be steel to steel, and just lubricate them from time to time by hand. So that's it for now, and we'll go into part 2.